All right, in this lesson, we are going to talk about systems of linear inequalities. And so with your inequalities, remember the less than sign kind of looks like an L. So if you struggle reading your inequalities, the less than sign looks like an L. And so when you are working with your less than signs, you are always going to shade below the y-intercept. You're actually shading below every point on the line, but if it helps to focus on the y-intercept, you can focus on that. Okay, and so if you have your greater than sign, you are going to shade above the y-intercept, above every point on your line. Okay, if you have the equal to option, whether it's greater than or less than, you are going to have a solid line. And if you don't have the line underneath, you are going to have a dotted or dashed line. Okay, it kind of corresponds to your closed circles versus your open circles, but only now instead of just talking about a point, we're talking about an entire line. Okay, and so when we talk about a system of linear inequalities, we're going to have multiple lines on our graph, and we're going to have a solution set, which is going to be the overlapping shaded region. So looking at this first example, first graph what I call the boundary line. Ignore the inequality symbols for now and just graph y equals x minus 4. And so our slope is 1, our y-intercept is -4, and so we would start at -4 on the y-axis, and our slope is 1, so we go up 1 over 1, up 1 over 1, up 1 over 1. And the more points you can fit on the graph, the more accurate your graph will be. And so I recommend graphing as many points that fit. Every point matters. Okay, and then for this particular inequality, because it is less than, I know I'm shading below, and because there's no equal to line, I know it's going to be dotted. And so if you want to just do a dotted line through these points, that'll work. Okay, and so to shade below, I draw an arrow pointing down from the y-intercept, and then I actually like to do it on all the points just so I can really narrow down what the region is. Okay, and so you don't want to exactly shade just yet because we're going to put another inequality on here, but you can kind of picture where your solution set's going to be. We're going to have to stay below this line. And so you can shade it now, but shade it kind of lightly so that you can still see what your solution region is. Okay, and so our next inequality is, I'm going to start with the boundary line, -x plus 3. And so our slope is -1, our y-intercept is +3. So start at 3 on the y-intercept, and we're going to go down 1, right 1, down 1, right 1. When it's -1, think of your rise as being down instead of up. Okay, the most common mistake I see is messing up negative slopes. And so if you have a negative slope, it should be a decreasing line going down the mountain. Okay, and so this one is our greater than, so we are going to shade above. And then we do have the line, and so it's going to be solid. And so connect your points with a solid line. And then we are shading above the y-intercept, above every point on the line. Okay, and so if I were to shade this whole solution set, I would be shading this region over here. This is above. And so the region that would have gotten shaded twice from the blue and the red is the small triangle to the right of your graph. And so let's see if this is dark enough. And so just this region over here. And so you can either just shade the original parts lightly or only shade the solution set. Okay, on number 2, starting with the top inequality, the boundary line is 2x minus 2, my slope is 2, and my y-intercept is negative 2. So start at negative 2, and we're going to go up 2 over 1, up 2 over 1, up 2 over 1, down 2, back 1, fill up every point. Okay, and so because it is a greater than sign, we are going to shade above. There's no line, so it's going to be dotted. There's no line underneath the inequality. So just do a dotted line through your points. And to shade above, we're going to be above every single one of these points. So if you were to shade it kind of lightly, it would be this region up here. Okay, for the second inequality, the boundary line is 4x minus y equals 4. That's in standard form, so our first step is to get it in slope-intercept form. So we're going to move the x to the other side. And then I'm going to write the x term first. So negative 4x once it's on the other side. And then technically there's a negative 1 here, so we have to divide every number by negative 1. And be careful when you do that. So I'm going to bring the inequality back. It's kind of sloppy to write it without the inequality, because now that we're dividing by negative 1, anytime you divide an inequality by a negative, it flips the inequality. And so now my inequality is less than or equal to. Okay, and then now when we simplify negative 4 over negative 1, it's positive 4. 4 over negative 1 is negative 4. Okay, and so my slope is 4. My y-intercept is negative 4. So start at negative 4 on the y-axis. And then we are going to go up 4 over 1. Up 4 over 1. Up 4 over 1. We could go down 4, back 1, as long as you have a positive slope. Oh. Okay, and so because this is our less than, we're going to shade below. I like to write the word below with a less than sign. And then because there's a line, it's going to be a solid line. There's a line under the inequality. Okay, and so connect your points with a solid line. And then above this line, just start drawing up arrows. The steeper the line, the harder it is to see what is above, but below would be down here. And so above the red line would be this region over here. Okay, and so the region that got shaded twice above the red and above the blue is the top left quadrant. So if I get red, let me get my purple. And so staying above the red, but then also staying above the blue. staying above the red and above the blue. Okay, so let me see. Get rid of that, get rid of that. So just this region over here. Whenever you have two lines, it divides your coordinate grid into 4 quadrants. And so you can think of this as quadrant 1, this little area is quadrant 2, this area of quadrant 3, this tiny area of quadrant 4. So your solution set is only going to be one of the quadrants. Quadrant 2, quadrant 3, quadrant 4. And so in this case, quadrant 3 was our solution. In this case, quadrant 1 was our solution set. Okay, next we are going to have more than 2, which is the algebra 2 piece of this. And then we are going to identify 3 points that are in the solution set. And so in order to be in the solution set, it has to be either in the shaded region or on a solid boundary. It can be on a line as long as it's on the boundary of your solution set and it's solid. Okay, so looking at our first inequality, it's in slope-intercept form. We have a slope of 5 and a y-intercept of -10. So we're starting at -10. Way at the bottom. And then we are going to rise 5, run 1. Rise 5, run 1. Okay, and then it is above and solid because we have a greater than with the line. So I'm going to go ahead and draw my solid line. And then I'm going to draw my arrows pointing up for above. Okay, and so we're kind of picturing this quadrant or this half of the graph shaded over here. Okay, for my next inequality, we have less than 1/3 x plus 4. And so my slope is 1/3, my y-intercept is 4. So starting at 4, we're going to go up 1 over 3. There's an intersection, we care about that. Up 1 over 1, 2, 3. Up 1 over 3. We go down 1, back 3, and still have a positive slope. Okay, and this one is below because it's less than and dotted. Okay, and so we're going to do a dotted line through our points. And we are going to shade below. Okay, and so right now we are in this quadrant down here. If these were the only 2 inequalities, this would be the region shaded twice. Okay, but now we're going to add the third inequality, which has a slope of -1 and a y-intercept of -4. So starting at -4, and then our slope is down 1, right 1, down 1, right 1. Make sure you have a negative slope for this. Okay, get every point so we can see what the intersections are. So here's another one. Okay, and then this one is solid and above. We have a greater than with the line. So we're going to draw a solid line. and then our arrows are pointing up. Okay, and so look at the shaded, or look at the region where all the areas or all the arrows are pointing, and you'll see that it's this triangle. Okay, and so if we were to pick solutions, we can pick anything in the triangle, so the origin would work. We could pick a point on the boundary, a solid boundary, so we could pick a point on the blue, so 2, 0 would work. And then even something on the green, we could pick -1, -2, -3, -4, 0. We can even pick this intersection if we wanted to, which is 1, -5, I believe. And so some points that you could not pick is anything on a dotted line. You can't pick even this intersection because it's not on a solid line. If it lands on a dotted line at all, it is not a solution. So this one, not a solution. And a lot of people will fall for that. This one would be a solution. It's only on solid boundaries. Okay, next, this x less than 4, if you remember, x equals 4 is a vertical line where x is 4. So 1, 2, 3, 4. It's a vertical line. So I'm going to make that blue. And so whenever you have a vertical line, your less than and greater thans, they can't really shade above or below a vertical line. And so it's just like our number line. If I have x less than 4, that's going to be to the left. Okay, and then it's going to be a dotted line. So I should have made this dotted. Let's see if I can change that. Okay, so there's our dotted line. And then we want to shade to the left of it. So picturing all of this shaded. That's x less than 4. The key is that remembering x is a vertical line. Okay, our next inequality is in standard form. And so our first step is to move the x. So now I have -4y less than -x plus 8. Put the x first. And if you want to go ahead and fill in a 1 right there, we are dividing everything by a -4. And so just like that last example, it flips your inequality. Anytime you divide by a negative. And then now we need to simplify. -1 over -4 is positive 1/4. And 8 over -4 is -2. Okay, and so my slope is 1/4. My y-intercept is -2. So up 1 over 4. Got an intersection. Up 1 over 1, 2, 3, 4. You can go down 1, back 4. Down 1, back 4. And then this will be dotted, so there's no line here, and above, because it flipped to a greater than. So we want to do a dotted line. And we are going to shade above. So we have to be above this red line, and then we have to be to the left of the blue. So kind of picturing ourselves in this top quadrant here. And then for the last one, we have 3x plus 2y is less than 24. We need to move the x, so it's minus 3x. So 2y less than -3x, write the x term first, followed by the constant. And then we are dividing everything by 2. And so our final answer, don't flip the inequality. We divided by a positive number. Okay, and so our slope is -3/2. Our y-intercept is +12. So 12 kind of falls off the graph by 2 units. And then we need to go down 3/2. 1, 2, 3/2. Down 3/2. Down 3/2. Make sure you have your negative slope. See some intersections. And then this is below and dotted. So we would have dotted line, and we would be shading below these points. Okay, and so that puts our shaded region up here. So stay below the green, to the left of the blue, and above the red. Okay, and so we can't pick any points on any of the lines. We have to be in the shaded region. So we could pick the origin again. We could pick even -1, 2. And this 1, 2, 3, 4, 5, 6. We could pick -7, 0. We could pick anything over in that purple region, just nothing on the line. Not even the intersections. No. So don't pick the y-intercepts. Don't pick anything on a line. They're all dotted. Okay, and so for these next two, we are going to write the system of inequalities that we are given in the graph. Okay, and so I like to start by writing the boundary lines. And so remember, these horizontal lines are y=, equations. Okay, and so this would be y=1. This would be y=5. Okay, notice we are below the 5, but above the 1. And so you can think of this as sandwiched between 1 and 5. And so you could either say y is greater than 1 and y is less than 5, and we should have the equal to option because these are solid lines, but most likely they're going to write it as the sandwich inequality. Okay, and then for this line right here, he has a y-intercept of -1. He has a slope of up 1/1, up 1/1, so +1. So we know we're going to have an x -1. We are shading above the points, and so that's going to be greater than or equal to since it's solid. Okay, and then lastly, the green line also has a y-intercept of -1. His slope looks like down 2/1, down 2/1, so -2. It's a negative slope. So I know I'm going to have a -2x -1. And if we draw some arrows to the shaded region, we are above the green line. Okay, and then that's 1, 2, 3, 4 lines, and we've got our 4 inequalities. 1, 2, 3, 4. Okay, and so for this next one, we have a vertical line. So let's start there. This vertical line is x = -5, and it's shading to the right. Okay, so we know that's greater than. So x greater than -5. No line because it's dotted. Okay, let's do the other dotted line. He has a y-intercept of -1 and a slope of up 1 over 1, up 1 over 1. So 1, and so we have y, and then we know we're going to have x minus 1, and we are shading above the dotted line, so we have a greater than with no line underneath it. And then lastly, for this solid line, he has a y-intercept of 0, so we're not going to have a plus number. And then it's going down 1, right 2, down 1, right 2, down 1, right 2. So -1/2 for the slope. So -1/2 x. And because it's a y-intercept of 0, we're not going to write +0. Okay, and then we are shading below every point on this line. So we're going to have our less than. And we do need a line underneath it because there is a solid line there. All right, this last one is an application problem. So we first have to write the system of inequalities, and then we will graph it. So it says Iris has $35 to spend for a small cookout. Hot dogs cost $3.50 for a package of 10, and buns cost $2.50 for a package of 8. She needs to buy at least 40 hot dogs and 40 buns. Okay, and so it says let H and B denote the number of packages of hot dogs. So that's important, the number of packages of hot dogs and buns, respectively, and that Iris may purchase. Write a system to represent this situation. Okay, and so if H is the number of packages of hot dogs, and B is the number of packages of buns. It says she needs at least 40 hot dogs and 40 buns. So we know that there are 8 buns per package. And so 8 times the number of packages of hot dog buns needs to be greater than or equal to 40. And so if you were to solve that, divide both sides by 8, that means we need B to be greater than or equal to 5. So we need at least 5 packages of buns. And then for the hot dogs, there's 10 hot dogs per package. So 10 times the number of packages, H, needs to be greater than or equal to 40. So that means H has to be greater than or equal to 4. So we need B to be at least 5 and H to be at least 4. Okay, and then now we need to talk about the money. And so for the money, she has $35 to spend. That means we can't spend more than $35. So something has to be less than 35, and that's how much she's spending. And so each package of hot dog is $3.50. $3.50 per package, not per hot dog. So $3.50 per package of hot dogs. And then buns are $2.50 per package. Okay, so that means $3.50 times H, the number of packages of hot dogs, plus $2.50 times the hot dog buns needs to be less than or equal to 35. We don't want her to spend more than what she has. So we've accounted for every number in this situation. And so in order to graph it, we would need to solve it. And so notice they're putting buns along the y-axis and they're putting hot dogs along the x-axis. Okay, so I can go ahead and graph the blue inequality. B has to be greater than or equal to 5. And so this is where B is equal to 5. And we need to be greater than that. B is kind of like our y. Y is greater than or equal to 5. Okay, and then for our H is 4 is right here. And we need to be greater than or equal to that. So we need to stay up in this top right quadrant. Okay, and so now to get this red inequality, since B is kind of our y in this situation, we're going to isolate B. And so we're going to move the H to the other side. I'm just going to write, I'll go ahead and write it like that. And so 250B must be less than or equal to, I'm going to write the H first. And if you want to drop the zeros, you can, plus 35. And then we are going to divide everything by 2.5. Same thing as 2.50. Okay, so B is less than or equal to, I'm going to use my calculator for this. Some of y'all could do it without it. I could, but I don't want to. So 3.5 divided by 2.5 is 1.4. And so in fraction form, that would be 7/5, and don't lose your negative. And then 35 divided by 2.5 is 14. Okay, and so my y-intercept is 14. I'm not going to call it B because we're using B. And then our slope is going down 7, right 5. So down 1, 2, 3, 4, 5, 6, 7, right 5. Down 7, 1, 2, 3, 4, 5, 6, 7, right 5. Okay, and so that is also solid. And we want to stay below this line. So that is a very small solution set. We have to stay in the triangle, this tiny triangle. Okay, so it says identify one point in the solution set for the system of inequalities. Describe what the point represents. So I'm going to pick the point right in the middle, which is 5, 6. So when H is 5, B is 6. It's kind of like your X and your Y. And so to interpret this, remember 5 is the number of packages of hot dogs, or H is the number. So 5 packages of hot dogs. And then B is 6, so that's 6 packages of buns would satisfy her needs. And so she needed 40 of each, would give Iris 40, at least 40 and at least 40 buns, and stay within her budget of 35. Okay, and so if you land anywhere out here, you're either not going to have enough or you're going to spend too much money. And so she has to stay within the shaded region. And we want to pick whole numbers because she's not going to buy half a package. And so this is where this can be useful in real life.